Hello, my friends, and welcome back to the You Can Do TV channel.
6 kilometers beneath busy shipping lanes, Peary's Formwork solutions quietly enable the HZMB Immersed tunnel to come together. Over 7 years, engineers plan, fabricate, and refine systems for wave walls, tunnel entrances, and main structures, adapting to architectural concrete demands. That long timeline alone already raises eyebrows. On-site support blends planning, material supply, and quality assurance, and suddenly the scale feels very real, turning collaboration into steady progress. Hidden along Denver water pipelines, cathodic protection keeps corrosion from quietly eating steel. Engineers install anodes and monitoring points, then balance electrical current so pipes stay stable underground. $2 million each year says how serious this is. When current levels settle, protection runs continuously, like an unseen shield working nonstop, and wow, failures become far less likely across buried utility networks citywide. The tension here doesn't come from speed or noise, it comes from scale. A tracked excavator edges closer to a ship propeller half buried at the waterfront, and suddenly the size difference stops feeling theoretical. This isn't about finesse, it's about force meeting resistance head-on, and you can already tell this propeller won't leave quietly. The excavator positions its tracks on uneven rockfill, stabilizing weight before the bucket reaches down into the water. Steel teeth clamp onto the propeller blade, testing how firmly it's locked in place. That first tug looks harmless, then the whole machine leans like it just realized how heavy this thing really is. The operator adjusts angle and leverage instead of brute pulling, using arm extension to shift pressure points. Water churns as the blade breaks suction from the seabed. Each controlled pull lifts the propeller a few inches, then settles it again to avoid slipping. This feels less like demolition and more like a strength contest that refuses shortcuts. The excavator repositions, applying force closer to the hub where resistance concentrates. As the propeller rises, revealing worn metal edges shaped by years of rotation. The machine holds steady while the load swings slightly, proving balance matters just as much as power here. No rush, no drama, just controlled muscle doing exactly what it's meant to do. This is heavy equipment work stripped down to its raw purpose. Long-term offshore operations define how oil and gas production is carried out in Equatorial Guinea's Alba field. Noble Energy supports the work as a non-operating partner, contributing technical coordination built over more than 2 decades. Offshore facilities manage extraction from multiple reservoirs, guiding hydrocarbons through controlled flow systems toward processing units. That timeline alone explains why field coordination matters so much. Production teams oversee pressure balance, separation, and handling of oil and gas condensate streams. Converted discoveries now operate as producing fields, maintaining steady output through monitored operations. Seeing separate finds brought into one working system can spark a quiet, "Oh wow!" Data tracking helps align field activity with safety and output goals. The scale feels calm, yet there's serious weight behind every valve and decision. The P95 ETEMAT-ISA track renewal train replaces rails and sleepers in one continuous pass. This specialized train advances along the existing railway, removing worn track components while preserving the original geometry beneath its wheels. Rails, sleepers, and ballast are handled in a single continuous workflow, turning the track itself into an active production line. The train is designed to perform removal and installation within the same movement envelope. That concept alone already shifts how large-scale rail work is usually imagined. As the train progresses, lifting units raise the old rails and guide them toward internal handling systems. These rails are transferred away in a controlled path instead of abrupt removal. Internal conveyors maintain a steady material flow along the length of the consist. Sleepers follow next, drawn upward and separated methodically, maintaining spacing and alignment throughout extraction. Ballast underneath is loosened and directed into screening units that remove fines and unwanted material. Each step feels deliberately linked, like a chain that refuses to break. Cleaned ballast is redistributed beneath the track formation to create a stable base for the new structure. Screened material is returned directly to the formation without leaving the worksite. New sleepers are then introduced from onboard storage and positioned accurately along the prepared bed. Alignment systems ensure spacing matches the original layout, keeping geometry consistent across the renewed section. There's a brief hold-on reaction when the sleepers land exactly where the old ones once sat. Following sleeper placement, new rails are fed forward and guided smoothly into position. Coordinated arms and rollers hold them steady, while fastening units secure each rail to the sleepers. Fastening operations are completed in sequence without halting the forward motion of the train. This entire operation happens while the train continues moving forward, eliminating the need for repeated stops. Seeing full rail strings locked in place so quickly brings a quiet jolt of surprise. Ballast distribution systems trail closely behind, delivering material evenly around the sleepers. Tamping units compact and stabilize the ballast, adjusting height and alignment to restore track integrity. Each tamping cycle is synchronized with the train's advance to maintain consistent geometry. Leveling systems fine-tune geometry to match the original profile, ensuring the renewed line is ready for service. This section makes the factory-on-wheels idea feel completely real. Throughout the renewal process, onboard control systems synchronize timing, spacing, and sequence across dozens of interconnected modules. Process coordination reduces idle intervals between individual renewal stages. Operators monitor progress from within the train, adjusting parameters to suit local track conditions without interrupting the flow. Removed materials are conveyed along the consist, keeping the worksite organized and uninterrupted. It's hard not to pause at how little downtime the railway actually experiences. What remains behind the P95 ETEM-ATISA train is a fully renewed stretch of railway, rebuilt under its own movement and ready for immediate use. The completed section meets operational standards immediately after the train clears the area. What appears to be a single machine is, in reality, a carefully ordered series of specialized systems working in strict succession. The idea of rebuilding an entire railway while rolling forward still lands with unexpected weight. By reducing manual handling and compressing multiple stages into one pass, this approach keeps large-scale track renewal efficient, controlled, and continuous. How do you move a 200-ton telescopic crawler crane? This transport report follows the relocation of a Raupen crane carrying 312 PS, built to lift up to 107 tons and reach 60 meters. Coordination comes first as drivers align transport units to manage a total weight of 91.5 tons and a 3.5-meter overhang. INFAHRER guide crawler sections onto carriers while logistics keeps timing tight. Didn't expect a crane this size to travel so cleanly between sites. FUHRPARK oversees each transfer to keep balance steady. That slow roll feels like controlled strength refusing to rush. Components are then reassembled and checked, ready for the next construction task. Marble walls are freed at Marmy Gherardi using water bags that split benches cleanly, then backhoes push blocks away. That pressure feels unstoppable. Heavy earth moving defines the pace at PLTA Poso 2 Unit 4-5 in central Sulawesi, where construction reshapes the riverbank into a working hydropower site. Excavators carve into compacted soil, removing unstable layers to form a controlled foundation zone. Each bucket load changes the landscape in seconds, and that shift matters. Material is relocated methodically, creating access paths and graded surfaces for the next operations. Slope preparation follows as machines trim embankments to precise angles. Steel mesh is installed across exposed surfaces, forming a structural net that locks soil in place. Concrete spraying teams move along the mesh, applying an even layer that binds the slope together. Seeing raw ground turn stable this fast feels like a quiet win. This reinforcement reduces erosion risk and secures the terrain against heavy rainfall. Further down the site, grading equipment smooths haul roads and work platforms. These surfaces support constant machine movement without interrupting progress. Excavators continue shaping drainage paths, guiding water away from active zones to keep operations steady. Concrete elements are positioned along critical edges, forming protective linings and structural boundaries. Workers coordinate closely with operators to maintain alignment and flow. Each finished section opens space for the next phase, keeping momentum intact. What emerges at PLTA Poso 2 is not a single structure, but a sequence of stabilized ground, reinforced slopes, and prepared corridors. Bit by bit, the site locks into readiness. This groundwork supports turbines, waterways, and power units still to come, anchoring the hydropower system long before electricity ever moves downstream. Stone blocks stacked along the Sydney Island breakwater reveal how coastal defense is built to stand against constant marine pressure. Material selection and placement planning come first, ensuring each block can resist wave force and shifting tides over time. Cranes lower stones into predefined zones, creating a stable base layer below the waterline. Layering continues as interlocking stones are arranged to distribute weight evenly across the structure. Crews adjust spacing to limit water penetration while allowing controlled movement during storms. You'd think gravity alone does the job, but placement accuracy quietly decides everything. Each section is checked visually before the next row is added, keeping alignment consistent along the breakwater's length. As elevation increases, larger armor stones are introduced to absorb direct wave impact. Equipment operators coordinate lifts with tide conditions, preventing drift and misalignment during lowering. The structure gradually extends outward, forming a continuous barrier that reduces shoreline erosion. Final shaping focuses on crest height and slope, guiding waves to lose energy before reaching land. Inspections confirm stability and continuity across the entire Sydney Island breakwater. Hard not to imagine how many storms this wall will quietly shut down over decades. The finished breakwater stands as a balance of weight, placement, and patience, built to work non-stop without moving parts, relying entirely on mass and arrangement to protect the coast. Operators bring the Frost MULTIDRILLXL Max into position, revealing how a compact drilling rig handles demanding water well work with surprising range. Site preparation focuses on stabilizing the base and aligning the mast to keep bore direction controlled. The built-in Fraste manipulator then manages automatic drill pipe loading from onboard storage, feeding up to 43-meter pipes without manual handling. That pipe handling feels like the machine refusing to waste motion. Rotary drilling follows, using direct or reverse fluid circulation depending on ground conditions, with switching handled directly on the rig. Cuttings are carried efficiently, while rotation stays consistent through varying layers. You'd expect pauses here, but the flow keeps pushing forward. For harder formations, air drilling comes into play as a DTH hammer is powered by a separate compressor, driving energy straight to the bit. As depth increases, operators adjust torque and feed to match resistance, keeping the hole clean and stable. Modular construction allows accessories to be fitted for geothermal drilling, geotechnical investigation, seismic tasks, or coring without reworking the entire setup. That flexibility feels like having several rigs packed into one frame. Throughout the operation, pipe handling, circulation choice, and drilling method shift smoothly to suit conditions underground. Final stages focus on reaching target depth and ensuring bore integrity before extraction or casing. Hard not to notice how steadily it keeps working, like it already knows what layer comes next. The Multi-Drill XL Max completes the job as a balanced mix of power, adaptability, and controlled automation.
How does red-hot steel become a perfectly calibrated wrench? Izelta's engineers make it happen. Steel bars arrive at the forging press, heated to precise temperatures to gain optimal hardness. Hammers and presses shape the hot metal into wrench profiles, followed by quenching and tempering to achieve strength without brittleness. CNC machines mill the jaws and holes for exact tolerances, while polishing lines remove surface imperfections. Each wrench is measured and tested for torque capacity and durability. Finally, protective coatings are applied before packaging. Seeing raw steel transform into durable tools is unexpectedly satisfying. Steel pipes aren't always shaped where they're made. The Moby Beager machine from Gelber Beager GmbH brings the power of industrial pipe bending directly to the site, turning heavy tubes into precise arcs without needing a full factory setup. Built for flexibility, it handles 80 kilograms loads and bends pipes up to 250 millimeters in diameter, with a working width of 1,200 millimeters. That's compact strength built for serious construction tasks. Its solid frame and balanced hydraulics make it stable even under full load. Each job begins by securing the steel pipe along the guiding frame. Hydraulic clamps press firmly, holding it in place before the bending rollers engage. The rollers, coated for durability, move with synchronized precision to ensure even curvature across the length of the pipe. And it's almost like watching raw strength being guided by calm control. The sound of hydraulic pressure rising marks the moment the steel begins to yield. You can almost imagine how much force flows silently through those rollers. N. Once the bending parameters are set, the operator activates the hydraulic drive. The Moby Beager central piston exerts controlled pressure, pushing the pipe gradually against the main roller. This eliminates the need for heat, keeping the pipe's internal structure intact. No distortion, no wasted effort, just clean bends that fit exactly as planned. Each bend carries the same consistency, whether the pipe is thick or thin. As the rollers move, sensors detect angle progression, automatically adjusting hydraulic flow. The operator can pause or fine-tune the bend in real time. This level of precision lets construction teams produce curved sections for railings, frames, or pipelines directly on site. It's clever how such a compact system replaces an entire workshop. Machines like this make modern fabrication look effortless. It's satisfying to see how pure mechanical power can achieve such accuracy. After the bend reaches the target angle, the clamps release smoothly and the finished section slides free. Edges stay clean, with no visible flattening or strain marks. A quick visual check confirms alignment before the next pipe is positioned. Every move shows how experience meets engineering efficiency. One mistake could waste material, so that smooth release always feels rewarding. And then, operators often comment that the Moby Beager saves both transport and setup time, especially in bridge, shipyard, or heavy steel assembly work. Seeing thick steel comply so neatly always hits differently. It's an elegant display of hydraulic control serving real-world demands. That blend of mobility and precision is exactly what keeps projects on schedule. You can see why crews trust it for demanding fieldwork.
The CNC brake press is a cornerstone machine in modern metalworking, known for its precision and efficiency in bending and shaping sheet metal across diverse industries. At its heart, this machine operates with a sophisticated system comprising several integral components. It begins with programming. Operators input bending parameters into the CNC system, specifying dimensions, angles, and material details. Once programmed, a flat metal sheet is carefully loaded onto the machine's bed and aligned against the back gauge for precise positioning. Tool setup is crucial next. The appropriate upper and lower dies are selected and installed based on the desired bend angle and shape of the part being fabricated. The CNC brake press then initiates the bending process. Its upper beam, equipped with the selected upper die, moves vertically under hydraulic or electric force. This controlled movement presses the sheet metal against the lower die on the bed, accurately folding it to the programmed angle. Upon completion of the bending sequence, the machine releases the formed part, which is then ready for further processing or assembly. This automated operation not only enhances efficiency by reducing manual labor but also ensures consistent, high-quality results with every production cycle. Key features of the CNC brake press include its exceptional accuracy, enabled by CNC controls that guarantee repeatability in bending operations. The machine's flexibility is another advantage, as it can accommodate a wide range of bending tasks, from simple bends to intricate forms, by simply changing out dies and adjusting settings as needed. This adaptability makes it indispensable across industries such as automotive, aerospace, electronics, and construction.
On the back of the leg. That's profile.
Observe engineers and robots seamlessly assembling gearboxes for onshore and offshore turbines. ZF Wind Power's facilities in Europe, China, India, and the US produce multi-megawatt gearboxes with capacities from 0.8 to 8 megawatts, ensuring efficiency in serial production. Operators and automated systems assemble, inspect, and test each component in-house, making every gearbox a precise balance of strength and mobility. Advanced R&D drives innovations in bearings and drivetrain designs to sustain larger rotors and challenging conditions. Didn't expect the coordination between humans and machines to be this seamless. Digital monitoring and smart solutions integrate electronics with mechanical systems. This setup looks like a brain and brawn combo. The outcome is wind energy that powers the world efficiently. Andritz Hydro provides advanced turbine diagnostics, precision machining, and component upgrades for hydropower plants. Using CFD simulations, modern automation systems, and high-efficiency runners, they restore and enhance performance. Services include rotor/stator refurbishment, control system retrofits, and hydraulic optimization.
The Swiss Mach desktop CNC machine represents a significant innovation in the low-cost machine tool market, which has long been dominated by low-quality imports lacking in innovation. Designed to combine the functionalities of both CNC lathes and CNC mills, the Swiss Mach offers versatility and precision at an affordable price point, unlike its expensive industrial counterparts. At the heart of the Swiss Mach is its robust construction, built from solid blocks of metal to ensure stability and durability during operation. Linear axes slide on large vibration-damping boxways, while rotary axes spin on oversized roller bearings, making it ideal for cutting metal with precision. One of the standout features of the Swiss Mach is its ability to quickly and easily change tools, thanks to its bidirectional 8-station tool turret with live tool capability. This allows for efficient machining of complex part geometries, as the machine can perform turning and milling operations seamlessly. The machine's powerful closed-loop BLDC milling motor, operating at 6,000 RPM, ensures smooth and precise cutting, resulting in smooth, flat surfaces on workpieces. Additionally, the Swiss Mach offers a variety of workholding options, including a 6 inches, 160 millimeters, 3-jaw chuck, and can accommodate a range of workpiece sizes and shapes. With a large 2 inches, 50 millimeters spindle bore for bar work and the ability to mount chucks and collet noses of various sizes, the Swiss Mach is capable of machining a wide range of parts, from small needles to large tubes and bars. The included ER40 tailstock further enhances the machine's capabilities, allowing for long parts to be machined between centers or for holding large cutting tools and deep hole drills. The Swiss Mach's work envelope is optimized for round and hex bar stock approximately the size of a 2-liter soda bottle or smaller, though larger diameter parts up to 10 inches can be machined with care. By default, the machine comes equipped with dual-shaft NEMA 24 stepper motors, offering precision while keeping costs low. However, users have the option to upgrade to O-drive servo motors for increased speed, power, and precision. In terms of setup, the Swiss Mach requires a sturdy table or desk, a regular residential outlet for power, and a computer to command it. Safety glasses are also recommended during operation. Future upgrades and features for the Swiss Mach include rigid tapping and spindle indexing, live tool capability on the lathe turret, B-axis locking and alignment pins, hard anodized boxways for long-term wear resistance, compatibility with touchscreen controllers and automatic tool changers, and more, ensuring that the Swiss Mach remains a versatile and adaptable machine for years to come. The SOFOP heavy-duty CNC lathe, particularly the HT series, represents a robust solution tailored for machining medium-sized components with precision and efficiency. Constructed with durability in mind, the machine's main components are crafted from cast iron, ensuring both rigidity and longevity. At the heart of the HT lathe is its unique bed design. In models HT6 and HT12, the bed features 3 guides, including a split central guide, facilitating smooth carriage movement alongside the tailstock and any steady rests required for the operation. The HT22 model boasts an enhanced bed with 4 guides, further enhancing stability and precision. Capable of accommodating workpieces weighing up to 22 tons and with dimensions of up to 2,000 millimeters in diameter and lengths exceeding 3 meters, the HT lathe offers substantial machining capacity. Versatility is a hallmark of the HT series, with options for different turning units to meet specific machining requirements. These include the 4-position square turret and the disc turret with up to 12 positions, complete with driven tools for enhanced functionality. Moreover, the machines can be configured with a vertical Y-axis and equipped with additional units for drilling, grinding, milling, and boring operations, expanding their utility across various applications. To further enhance productivity and precision, the HT lathes can be outfitted with accessories such as workpiece probes and tool probes, ensuring accurate measurements and efficient tool changes. For added convenience and safety, Optional features like the complete casing for models HT6 and HT12 are available, providing additional protection and containment during operation. Additionally, the lathes can be equipped with one or more steady rests, available in different models and clamping ranges, enabling stable support for long workpieces. Heiligenstedt's commitment to perfection in machine tool manufacturing is deeply ingrained in its ethos. With a rich heritage spanning over a century, the company has continually evolved, embracing cutting-edge technologies and innovative methodologies to stay ahead of the curve. The Renewal series represents the pinnacle of milling machine technology, redefining precision and versatility in the machining industry. Utilizing advanced CNC controls and high-precision components, Renewal machines offer unrivaled accuracy and repeatability, making them ideal for a wide range of applications, including aerospace, automotive, and mold making. Whether tackling complex contours or intricate details, Renewal machines deliver exceptional performance with every cut, enabling manufacturers to achieve the highest standards of quality and efficiency. Designed to handle the most demanding turning operations, the Renewal series of heavy-duty lathes is renowned for its robust construction and unwavering reliability. Built to withstand heavy workloads and harsh operating conditions, Renewal lathes deliver exceptional precision and stability, even when machining large and challenging workpieces. With features such as rigid bed designs, powerful spindle motors, and advanced control systems, Renewal lathes empower manufacturers to tackle the toughest turning tasks with confidence, ensuring consistent quality and performance day after day. The Renewal series of CNC turning machines represents the epitome of efficiency and productivity in the machining industry. Equipped with state-of-the-art CNC controls and innovative automation features, Renewal machines enable manufacturers to optimize their turning processes for maximum throughput and precision. Whether producing small batches or high-volume runs, Renewal CNC turning machines offer unmatched versatility and performance, allowing manufacturers to achieve faster cycle times, reduced setup times, and improved overall efficiency. The Zimmermann FZ33 portal milling machine is a state-of-the-art piece of equipment designed to meet the demands of modern manufacturing. It combines decades of experience with cutting-edge technology to offer unparalleled performance and flexibility. With its modular design, the FZ33 can be quickly adapted to meet individual customer requirements, making it ideal for a wide range of machining tasks. It boasts impressive specifications, including accelerations of up to 5 meters per square second, feed rates of up to 60 meters per minute, and rotation speeds of 360 degrees per second on the A and C axes. The machine's large axis length of up to 40 meters enables the machining of large volume components with exceptional precision and efficiency. Its rigid design ensures stability and accuracy, even during high-speed finishing operations. Pre-loaded drives accelerate the portal and Z-axis via rack and pinion drives, while the A and C axes are supported by holding torques of up to 3,000 Newton-meters, ensuring high levels of accuracy and reliability. Equipped with a powerful 45-kilowatt spindle, the FZ33 can quickly remove excess material at high chip rates before finishing parts at speeds of up to 25,000 revolutions per minute. Its versatility makes it suitable for a wide range of industries, including aerospace, automotive, and manufacturing. Whether machining complex components or large surface areas, the FZ33 delivers exceptional results with the lowest possible cycle times and maximum efficiency, making it ready to tackle the challenges of modern manufacturing.
Positioning the wheel set on the lathe bed marks the start of machining operations. Initial alignment ensures each wheel is centered precisely. The scale and accuracy of the machine impress engineers immediately. Operators set the cutting parameters, and the lathe begins machining the wheel tread and flange. The lathe's spindle load and feed rates are monitored in real time to prevent overcutting. Cutting forces are adjusted automatically to maintain consistent surface finish across the wheel tread. The CNC-controlled system monitors dimensions continuously, adjusting for wear and ensuring uniform profiles. It is remarkable to see how technology guarantees safety and performance on every wheel set. After turning, wheels are measured using integrated axle and wheel systems to verify tolerances. Completed wheel sets are ready for reinstallation on locomotives, coaches, or wagons. The gantry milling machine FZ40C is set into action as a solid metal block is loaded onto its cast iron base. Operators begin by securing the workpiece, ensuring stability for machining high-strength materials. The integrated table supports weights up to 16 metric tons, allowing large-scale operations without compromising rigidity. For full cuts, the spindle uses a feed rate of 100 millimeters per minute, with a spindle load of 85%. When contouring, the depth of cut is 1.25 millimeters, radial engagement 55 millimeters, feed rate 8,000 millimeters per minute, spindle speed 700 revolutions per minute, and spindle load 75%. The spindle engages the workpiece, moving along the X, Y, and Z axes. Sensors continuously monitor vibration and spindle load, ensuring consistent cutting performance. The force and speed of the spindle during the full cut show the engineering power behind this machine. Initial passes shape the contour while monitoring spindle load, feed rates, and depth of cut. Operators note subtle changes in material resistance, adjusting feed rates for optimal surface finish. Operators observe readouts carefully, adjusting for optimal cutting efficiency. The machine handles both aluminum and harder materials with ease. Sidewalls filled with special concrete damp vibrations, enhancing surface quality. Watching the workpiece transform under controlled milling is fascinating. Multiple cutting tools are used sequentially, each performing precise operations that together define the final geometry. After milling, surfaces are measured for tolerances and flatness. Adjustments are made if necessary, and the part is removed from the gantry. Seeing the completed piece, perfectly machined and smooth, brings a sense of satisfaction. The workflow demonstrates integration of advanced CNC technology with robust mechanical design. Operators rely on software-controlled sequences to maintain repeatable quality while maximizing machine efficiency. Heavy-duty construction and vibration-reducing features ensure even large, dense components are machined accurately. The combination of speed, force, and controlled motion showcases the pinnacle of modern milling solutions. Final inspections confirm surface finish, dimensions, and consistency. Parts are then ready for their application in demanding industrial contexts. It is striking how every step, from securing the block to the last cut, contributes to a finished product of high performance and quality.
In the world of heavy steel fabrication, precision and power are not optional. They're essential. When it comes to shaping thick steel plates into large diameter cones with absolute accuracy, there's one machine that sets the benchmark. The Big Cone Diameter Plate Roll Bending Machine by OMCCA, distributed by ADAM Trade of Modi Primor, a cutting-edge solution engineered to meet the demands of modern industry. The Big Cone Diameter Plate Roll Bending Machine from OMCCA is an advanced heavy-duty forming solution engineered for rolling large diameter cones and cylindrical components with remarkable precision and efficiency. Designed specifically for fabricators handling thick steel plates and complex geometries, this machine enables the production of wide-angle conical sections, transitions, and heavy steel shells used in industries such as wind energy, pressure vessels, shipbuilding, steel construction, and chimney fabrication. Unlike conventional bending machines, this OMCCA model is purpose-built for conical rolling. Its core advantage lies in its independent hydraulic movement of the side rolls, which allows precise angle adjustment between the rolls. This variable geometry enables differential force distribution across the plate, making it possible to form cones with large diameters and varying apex angles, all while maintaining a consistent curve without plate deformation or stress concentration. The upper roll, constructed from hardened alloy steel, applies high downward force, while the two side rolls adjust independently to create the necessary taper. This mechanism ensures perfect edge alignment, vital for accurate welding after rolling. The system also includes synchronized rotation of the rolls, which allows controlled feeding and pre-bending of the material. This is especially crucial when dealing with thick plates ranging from 10 mm up to 80 mm or more. To enhance operator control, the machine is equipped with an advanced CNC or NC control panel, offering programmable cone dimensions, rolling speed, and taper angle. With a user-friendly interface and real-time monitoring, it ensures repeatability across multiple production cycles. Optional features include side supports and top supports, which stabilize the plate during the rolling process, especially important when forming very large or long cones. The rigid machine frame is built to withstand extreme rolling forces, ensuring long-term structural integrity and minimal deflection. In addition, infrared sensors, pressure limiters, and safety interlocks are integrated into the system to maximize operator safety. Turning logs into usable output is exactly what the Bandit Model 3680 Beast Recycler is built to handle. The machine is engineered to process large log volumes without interrupting material flow. Material enters the feed system and meets the cutter mill assembly, where rotating cutters slice instead of striking. Unlike traditional grinders that rely on repeated impact, these cutter mills separate material through controlled cutting paths. This approach reduces unnecessary fines while keeping output more consistent across mixed inputs. You can feel the difference in how clean the breakup stays, even before the discharge tells the story.
This conveyor discharges material to a height of 18 feet, providing plenty of height for loading open-top trucks, even in muddy conditions. A hydraulic thrower for loading and opening trailers is available as an option for the 3680.
The cutters shear layers apart, rather than smashing them randomly. Logs and brush follow a similar route, with fibers split along natural resistance lines. This cutting action preserves usable particle structure instead of breaking everything into fragments. Wood fibers remain more uniform, which directly improves downstream usability. Pallets and demolition debris introduce irregular shapes, pushing the machine to adapt without slowing the flow. This is where the Beast earns its name without needing to prove anything twice.
And Cummins power units are available as options, ranging from 440 to 700 horsepower. Our famous patented cutter mill is standard on the 3680, ensuring that all material is processed efficiently using a minimal amount of fuel. The fuel savings using the cutter mill system over conventional grinders can be as much as $40,000 per
Material sizing continues through screen selection, allowing operators to tailor the end product for reuse or resale. Adjustments here control how aggressive the reduction stays without overworking the load. Different screen configurations allow the same machine to support multiple end uses. Throughout operation, the Model 3680 maintains steady throughput by balancing cutter speed and feed pressure. Heat buildup stays manageable because material is separated efficiently, not punished repeatedly. Maintenance intervals benefit from this design as components experience less chaotic stress. Less violent material handling directly reduces wear across critical components. This steadiness helps crews maintain predictable daily production. That kind of efficiency saves more than time, it saves patience.
The width is 9 foot 7 inches, and the length is 39 feet. The weight is 57,500 pounds. An optional mill to our popular cutter mill is offered for the 3680. The Dragonhead was designed for increased production when processing some of the easier materials to break down, such as pallets, green waste consisting mainly of...
Once processed, material exits ready for its next role, whether as recycled aggregate, biomass fuel, or reusable fill. The Bandit Model 3680 Beast Recycler doesn't try to disguise what it does. It simply keeps material moving forward instead of letting waste stall the job. It just keeps converting problems into inventory, one load at a time. Scale changes expectations the moment XL furniture comes into view. Inside Karagiannis Carmeliatis SA, furniture production is treated less like individual pieces and more like a coordinated flow of decisions, materials, and timing. This is the kind of place where hesitation doesn't survive long. Raw materials are selected and staged with clear intent before moving deeper into the factory. Wood panels, components, and fittings are tracked from arrival, ensuring consistency before any shaping happens. Storage and handling aren't passive here. They guide what moves next and when. You can already tell waste isn't welcome in this system. Clear material separation reduces unnecessary handling across shifts. Cutting operations follow, where panels are sized and divided according to production plans. Machines handle repeated dimensions while maintaining uniformity across large batches. This phase sets the pace for everything downstream, because errors here multiply later. Mess this part up, and the whole day feels longer. Stable output at this stage helps maintain predictable assembly flow. Machined parts transition into forming and assembly preparation. Edges are finished, connection points are defined, and components are grouped by product type. Rather than rushing forward, each section feeds the next with controlled timing. That restraint keeps the line calm instead of chaotic. Component grouping simplifies task assignment on the assembly floor. Assembly lines bring structure to volume. Furniture frames and surfaces come together in sequences designed for repetition without confusion. Workers focus on specific tasks, allowing speed to build without sacrificing consistency. There's something reassuring about repetition done right. Surface treatment and finishing follow, giving furniture its final character. Coatings and textures are applied evenly across batches, ensuring the same result whether one unit or hundreds pass through. Drying and curing time is respected instead of rushed. Skipping patience here would be obvious later. Uniform finishing supports consistent appearance across large orders. Quality control steps in before anything leaves the floor. Finished furniture is checked for alignment, stability, and finish integrity. Items that don't meet expectations are redirected without slowing overall output. That quiet refusal to compromise says a lot. Packaging and logistics complete the cycle. Products are prepared for transport with protection suited to mass distribution. At XL Furniture, part of Karagiannis Carmeliatis SA, scale isn't about speed alone, it's about keeping order while everything moves. A forestry site feels different when the Processadora 600 from MONRA Forestal rolls into position. Logs stop being random material and start following a clear sequence shaped by mechanical control and timing. This machine decides the pace long before the first cut happens. The incoming log is aligned and secured by the processor head, preventing lateral movement during handling. Gripping arms stabilize the trunk, while feeding rollers prepare it for controlled advancement. Positioning here defines everything that follows, and small adjustments make a visible difference down the line. You can feel how much depends on holding the log steady. As feeding continues, the cutting unit trims sections to predetermined lengths. The system advances the log smoothly, measuring and cutting in a single continuous motion rather than stopping between steps. Length accuracy stays consistent, even as log diameters vary. That flow saves time without turning the job into a rush. Once cut, the delimbing phase strips branches cleanly as the trunk moves forward. Knives adapt to surface changes, keeping contact without slowing overall movement. Material exits this stage, ready for stacking or transport. Seeing branches disappear this fast never feels routine. Processed logs are released in an orderly sequence, keeping the work area clear. Operators maintain spacing to avoid pile congestion and unnecessary repositioning. The machine stays focused on repeatable output instead of constant correction. No extra gestures, just controlled motion doing its job. By the end of the cycle, raw timber has been standardized for downstream use. With the Processadora 600, MONRA Forestal emphasizes control, consistency, and steady output over brute force. That balance keeps forestry work efficient without forcing the pace. How do OLWO wood chips become GUTEX wood fiber insulation boards through a closed material cycle? OLWO wood chips arrive from Swiss sawmills and immediately enter a controlled material flow shared with GUTEX and INTERSPAN. That handoff keeps resources moving instead of piling up. The chips are cleaned and screened to remove contaminants, then reduced to uniform fiber size. Moisture levels are adjusted so fibers bond evenly later. Light, selective forestry upstream ensures fresh residual wood keeps coming without exhausting the forest base. This loop feels designed, not improvised. Fibers move into forming, where mats are built to define thickness. Heat and pressure activate natural binders, creating dense yet breathable boards. A closed water circuit supports production while limiting discharge. No wasted motion here. Everything circles back. Cutting and finishing shape panels for facade, roof, and interior use. Quality checks verify strength, flexibility, and consistency across batches. That consistency matters once panels leave the factory. From OLWO chips to GUTEX insulation boards, the cycle stays local and renewable for modern building needs. The Albach Diamant 2000 with a 790 horsepower MAN engine handles wood chipping duties inside a 2.9 megawatts biomass power plant. The Albach Diamant 2000 from Gullet GmbH enters the scene not as background support, but as a key link between forestry residue and usable fuel. This is one of those moments where scale suddenly feels very real. Logs and bulky wood material are fed steadily into the machine's wide intake. The Diamant 2000 uses a 790 horsepower man engine to keep cutting force stable under continuous load. Material is pulled inward, broken down, and reduced into uniform wood chips suitable for combustion systems. You don't expect that much wood to disappear this fast. Inside the shredding chamber, rotating components apply consistent force rather than short bursts. This keeps output size predictable and avoids irregular fragments that could affect downstream handling. Throughput reaches roughly 330 to 350 cubic meters per hour, matching the power plant's fuel demand without creating bottlenecks. That output rate changes how you think about feeding a power plant. Processed chips exit the machine in a controlled stream, ready for transport to storage or directly into the fuel system. Consistency here matters, because uneven material would complicate feeding screws and burners later on. The Diamant 2000 stays locked into a steady rhythm of intake and discharge, maintaining flow without constant adjustment. No drama, just relentless volume control. What stands out is how the machine adapts to mixed forestry material. Branches, thicker sections, and irregular pieces are handled in the same pass without stopping production. The man engine delivers torque that keeps rotation stable, even as resistance changes. That kind of stability saves operators from babysitting every load. At a wood chip power plant like this, reliability is not optional. Fuel supply has to match generation needs hour after hour. By converting raw wood into consistent chips on site, the Albach Diamant 2000 supports continuous energy production instead of short reactive cycles. It's hard not to respect a machine that keeps the whole system calm. From raw forestry material to combustion-ready chips, the Diamant 2000 proves its role as more than a shredder. It becomes the point where natural material is shaped into a reliable energy source for a working power plant. Every finished barrel at Tonelería Nacional carries more than wood. It carries control over flavor, aging, and consistency. Selected oak staves arrive dried and sorted, each piece evaluated for structure and grain direction before entering production. The staves are arranged into a circular form, creating the initial barrel shape without fasteners. That moment already hints at how much the final result depends on balance. Heat is then applied to soften the wood, allowing the staves to bend inward. This controlled heating draws the structure together, forming a stable body ready for shaping. Metal hoops are placed to lock the form, holding tension evenly around the barrel. There's a quiet, "wait, that worked" feeling when the curve holds perfectly. Once assembled, the barrel interior is exposed to toasting. Time and temperature are adjusted to influence aroma transfer and interaction with wine or spirits. This stage determines how the barrel will contribute notes over years of aging. This is where patience quietly decides future taste. After toasting, heads are fitted, sealing the barrel while preserving its internal character. Finishing steps follow with surface sanding and inspection. Each barrel is checked for tightness, alignment, and uniformity before leaving the workshop. It's hard not to think about how many future bottles depend on this one object. Final markings identify origin and specifications, completing the production cycle. What leaves Tanneleria Nacional is not just a container, but a functional tool shaped by sequence and restraint. Barrel making here feels less like assembly and more like timing. By guiding wood through heat, pressure, and form, the process delivers barrels ready to shape beverages long after production ends. Every log shaped for a custom-milled log home must carry load, align with its neighbors, and settle naturally once assembled. There's no shortcut here, because wood always remembers how it grew. The first stage focuses on trimming the log to length while maintaining reference points along its centerline. Cutting heads remove excess material gradually, keeping the profile consistent for later fitting. This is where patience quietly does the heavy lifting. Once squared and stabilized, the log moves forward for milling, where rotating cutters shape the exterior faces to match the home's design plan. Drilling follows, creating channels for fasteners and utility paths. These holes must align perfectly with adjacent logs, or the stack will drift off pattern over time. Miss by a fraction, and the whole wall will argue back. Notching comes next, carving interlocking joints that allow logs to settle naturally while staying locked under load. A separate operation prepares logs destined to meet custom timber trusses. These pieces are trimmed differently, with angled cuts and adjusted profiles to support roof loads without stress transfer. It's oddly satisfying to see geometry calm raw wood like this. Throughout the process, machines guide the cuts, but operators constantly verify alignment, grain response, and surface behavior. That mix of judgment and steel is what keeps a home standing decades later. By the end, each log is no longer just timber. It's a numbered component ready to fit only one place in the structure. Christian Supper operates a wood chipping system capable of processing thick trunks and thin shrubs into consistent wood chips. Logs don't arrive uniform or polite, and that's exactly what this setup is designed to confront. Wood never shows up cooperative, and that's half the challenge. Material is positioned and guided toward the intake, where heavy-duty rollers pull it forward at a controlled pace. Larger trunks require steady alignment to prevent twisting, while lighter branches are grouped to maintain consistent feed pressure. It feels like convincing chaos to walk in a straight line. As the cutter system engages, rotating blades shear the wood into uniform chips, breaking down fibers without tearing or splintering. Chip size is governed by blade spacing and feed speed, adjusted constantly to match the mix of material. Too fast, and chips lose consistency. Too slow, and output efficiency drops. That balance decides whether the pile grows clean or turns stubborn. Fresh chips exit the housing in a steady stream, carrying moisture and texture that signal proper cutting. Handling thin shrubs presents a different task. Their flexibility can cause bounce back, so pressure and angle are modified to keep them committed to the cut. Yes, branches fight back more than you'd expect. Despite the variety of input, the system maintains a predictable result, converting uneven material into usable fuel stock. Throughout the operation, Christian Supper monitors flow, listens for load changes, and adjusts feed rhythm on the fly. One wrong decision echoes immediately through the machine. By the end, what entered as random growth leaves as consistent wood chips, ready for energy use or processing. Large wooden vessels demand more than size. They demand control, timing, and restraint, especially inside the workshops of Tonneleri ERABLE producing traditional foudres. Each vessel is designed to hold volume without losing structural calm. Big wood does not forgive rushed decisions. Selected staves are prepared according to thickness and curvature, adjusted to support wide diameters without internal stress. The wood is positioned upright, allowing natural grain behavior to guide assembly. Gravity quietly becomes part of the team here. As staves rise into a circular form, temporary hoops secure alignment, while gaps are corrected by incremental pressure rather than force. Heating follows to soften fibers, allowing controlled bending. Moisture and warmth work together, helping the structure accept shape without cracking. This moment decides whether the wood agrees or resists. Once curvature stabilizes, permanent metal hoops replace temporary ones, locking geometry in place. Exterior surfaces receive the attention through hand sanding, focusing on uniform thickness and long-term stability rather than visual polish. Once prepared, a protective outer coating is applied to shield the wood from humidity variation, while still allowing controlled exchange with the environment. Bases are fitted with precision-cut joints, sealed through compression rather than adhesives. Final inspections focus on balance, sealing integrity and uniform tension across all hoops. Throughout fabrication, Tonneleri ERABLE relies on experience rather than shortcuts, guiding each foudre toward durability measured in decades. When something this large holds liquid safely, that silence means success.